And I just have to hit play for this. I can't get to the, there it goes, the play the PowerPoint slideshow. View show. Is that a thing? Start. Okay, so, sometimes when you're looking at scientific notation and you're having to record numbers, it can be kind of confusing. I don't know if it's that confusing, but it can be kind of confusing. You have blanks on your paper, on your PowerPoint, and most of your blanks are the red words. And we had done at the beginning of class, you had a triple beam balance, and I asked you to record the mass. We knew for sure the hundreds place, 10 place, 1 place, and tenths place. And then you had to estimate that last uncertain decimal, that hundredths place. And so any measurement is going to have a degree of uncertainty. And, you know, there's no instruments that can tell you an infinite number of decimal places for sure. And that's okay. So any measurement is going to be slightly uncertain. And it's going to be that last digit that's going to be uncertain. Like I said, no instrument can read an infinite number of decimal places. And so if we look at these two balances, this balance reads, and it can read, you know, a quarter of an ounce or whatever. And then here we have on the right side, we have an analytical balance, and that's similar to the one in the lab where you close the door and it can read to 4 decimal places. So of course, this one on the right is going to have less uncertainty. And so we're going to try to use the best instruments we can while we have class. So I'm sure you've all seen this little analogy where you have these little arrows. This is in every science book ever. Accuracy is if your answer agrees with the accepted value. You know, if you do the density of water and you do the calculations of it, you should get 1 gram per centimeter cubed. That's the accepted value. So if you get 1, then you're accurate. Now, if you are looking at precision, that is going to be if your measurements agree. So if I'm supposed to get 1 gram per 1 gram per centimeter cubed for water, and I get 1.3, but I get 1.3 3 times over and over and over again. Anyway, that would be precise. And then ideally we want to be precise and accurate. So the last picture. Something you've heard before? Yeah. All right, so there are a couple types of error. And when I'm working with people in the lab, most of the time they end up with a systematic error. Let me give you an example. If I'm working with students and they don't know how to read a graduated cylinder, for example, they may look at it and they may read it from right here. They may stand up tall and read it from here. And so if I'm looking at this, it really looks like there's 35.2 milliliters of water in there. It really looks like that sitting up. So every measurement they would make, because there's actually about 37. Yeah, there's actually about 37 milliliters in there. So every single measurement would be off, but it would be consistent. So that's a systematic error. So that's where, or like your triple beam balances for yesterday. Like if you got 5.4 for your mass, the real mass is 5.6. If you measure that over and over again, your measurement would be consistently low. Okay, and so that just usually comes from poor technique, like not looking at the meniscus at eye level, or from a poor instrument. So there's some rules for significant figures, and we did this yesterday. Any number, 1, 2, 3, 4, 5, 6, 7, or 8 or 9, any integer, an integer is a counting number, right? Math class is fun. Those are always significant. And so here's the first opportunity that you have to practice. So I want you guys on your boards, I want you to write for me how many significant figures 3,456 has. So just kind of write it down, kind of turn it over, and then we'll all show me at the same time. And you know, this is not getting graded right now. We're trying to find out, you know, if you need help. Alright, so let's see what you got. Alright, 100% on that one. 4, yay. Alright, cool. So piece of cake on that one. Any non-zero digit or integer has is significant. So that has 4 significant figures. So take your pencil and write that down so that when you look back at your notes, you'll have that down. right, looking good, guys. So the next rule that we're going to be looking at is if we're talking about zeros. Zeros are where things get a little hairy. I really like to spend a lot of time looking at why zeros matter sometimes and why they're less significant sometimes. And that we did that with lab equipment, so it actually makes sense to you. So when we're writing down zeros, leading zeros do not count. And so here's an example that has some leading zeros. So take a look at it. Think about what we've done in class, and then write down the number of significant figures on your whiteboard for me. All right, let's see what you got. All right, thank you. I have a couple people saying 4, and I have most people saying 3. So let's talk about it. These are leading zeros. So leading zeros are zeros that come first, and they're not like sandwiched between another number and something like 4. Like if we had a 1 here or a 2 in front of the zeros, then they would count. But these are leading. This 0 here and this 0 here, they're both leading. So those are not going to be significant. So the answer here is 3. Okay? And the way you can tell if a 0 is going to be significant or not, if I rewrote this in scientific notation, it would be 4.86 times 10 to the negative second. You wouldn't write these two zeros, would you? So that's kind of how you can tell. Going on, if we have zeros that are captive, that means they're sandwiched between two significant figures. They're going to be significant. So check out this number, kind of brainstorm whether you think this 0 here would be significant or not, and then give me your answer on your board for how many significant figures we're dealing with. All right, let's see it. All right, awesome. So everybody said 4, and that is true. So this is a captive 0 in between the 6 and the 7, and it is significant. So get your answer down as 4 in your notes for later. All right, so next we have trailing zeros. Trailing zeros are those at the end of a number. They're only going to be significant if the number contains a decimal point. So take a look at 9.300 and think about it, and then write down what you think this could be on your board. All right, what you got? All right, so we have mostly 4s. I see a 2 and I see a 3. So let's talk about it. When I'm looking at 9.300, there's a decimal present. And so these are trailing zeros. That means they're at the end. And they are significant because there's a decimal present. They're significant not just because that's a rule and because I told you. It means that this would be like our analytical balance in the lab. It goes to 4 decimal places, but let's say this balance goes to 3 decimal places. That means that I know for sure that I have 3/10, 0 hundredths, and then this is my uncertain digit that's estimated by the balance. And if you actually look on our balances in the lab, they'll say plus or minus 0.0001. So that last digit on that balance is uncertain. Okay, and so these are significant not just because I'm telling you or because I have a decimal. They're significant because this instrument can measure to the nearest thousand. Okay, so that has 4 significant figures. Get that down. All right, now this little point here is going to be really important later when we do conversions, and we're going to save that for maybe like a month or 2. But if 1 inch is exactly 2.54 centimeters, or yesterday we had done an example where 1,000 grams was a kilogram, when 2 numbers are equal and I am given this exact number, this conversion, something, or like if I have 12 eggs, like that's an exact number. Those are going to have infinite significant figures. So that's going to be important when we get into this a little bit and we're having to kind of limit our answer. So this is never going to limit you. All right, so let's do some practice. Oops, just kidding. Go ahead and write down on your board for me how many significant figures this is. Now, don't go back and forth with your pencil. Just wait till we're done. You can write them all down. So write me down how many significant figures this guy has. And I think your paper has them underlined, so go ahead and turn your paper over for me. Thanks. You probably didn't even notice, but some of you might have, so.
I think I got this right.
Yeah. All right, so let's just go and do that first one, 5. Now, don't write anything down. You everybody got 5? Looking good. Good. All right, so don't turn your paper over. Leave your pencil alone. So, yes, it is 5 significant figures. Here we have 17.10. So, guess what you think is the correct number of significant figures here. Remember our rules about zeros and final zeros or trading zeros. All right, what do we have? 4. Everybody says 4. Yay! All right, think you're learning stuff. That's good. And, you know, this means that whatever we mass this in or on, it gave a number to the tenths, or excuse me, hundredths place. So 4 is correct. So here's another one. This will get a little harder. We have 100,890. So check that one out. Write down what you think. Be careful. All right, let's see what you got. All right, I have mostly 5s, and then a couple of you guys said 6. So let's look at this. Trailing zeros or final zeros, zeros at the end of a number, are only significant if there's a decimal present, and there's not a decimal present. If I were to take and put a dot on this board right here, then that 0 is now significant. But I don't have a dot. I don't have a decimal. And so whatever instrument this was that measured this volume only was able to give me to the nearest tens place. And this one is not significant because I don't really know what the ones place is. So it's 5 significant figures. Good job, everybody. So here's another one. Think about scientific notation and what that does. And get me an answer. Nice to you, friends. Ooh, I hear some debate on this one. All right, let's see what you got. Mostly 3s, but I do see a couple 4s. So let me tell you about this. When I have things in scientific notation, the great thing about scientific notation is it is automatically going to remove any placeholder zeros. And we talked about placeholder zeros yesterday. So these are never, whatever's on this 10, even if it's negative 12 or positive 12 or 10 to the 23rd, they're going to be insignificant. So this is the number that has the sig figs here. So it's just going to be 3. And most of you got that, but a couple people did put 4. So let's take a look at 0.0054. That was quick. All right, let's see what you got. I think I'm just going to go home now. All right, I've got mostly 2s. I did have 1 4. Let's talk about it. So these are leading. It's okay. No, look, we're learning. It's fine. You know what? Yesterday when you came into my room, you didn't know what a significant figure was. You didn't even know that, right? So you're doing great. But look, these are leading zeros, and they're not sandwiched between anything. So these are placeholders, and I can tell they're placeholders because I could write 5.4 times 10 to the negative 3rd, and those would be gone. That's how you can kind of check. Okay? So that has 2 sig figs. All right, so let's check out the next one. 3,200,000. All right, let's see what you got. All right, cool. I see 2s, mostly 2s. I saw a 4 and I saw a 6. So let's talk about it. These are trailing zeros and there's no decimal present. So that means that I'm just dealing with 1, 2 significant figures, and that's it. So I think, yeah, that's the last one. So take your pencil out and jot these answers down so you have them to refer to. And I'm going to show you my little trick now that we understand it. Yeah. Were you using that at all?
I didn't really use it.
You don't really need to, right? Yeah. But I'll show it to you just in case you want to see. In case anybody ever tells you. Where's my mouse? There it is. Alright, so let me exit out of that little PowerPoint real quick. Time delay. I want to show you a little trick that I like to use. And honestly, to me, like if you don't understand it enough not to go by this little saying, then you don't understand it. But I mean, from what you just showed me, only 1 or 2 people missed any of those questions, so you understand it. But I just want to show you a little trick if you need something to help you or help jog your memory. So here's the United States. It's beautiful, I know. There's Texas or something. No, there's the Atlantic Ocean over here. And here's the Pacific Ocean over here. So, if the decimal is present, we're going to start on the Pacific side of the United States. If the decimal is absent, we're going to start on the Atlantic side. So let's take a couple of those sort of like examples that we were just looking at. If we have 0.0054, the decimal is present, so I'm going to start in the Pacific. And what you do is you start on this side of the decimal over here, or this side of the number over here, and you're going to start counting at the first non-zero digit and everything after it. So let's look. No. 1, 2. Okay, so you start counting at the first non-zero. So let's look at a different one. The decimal is absent, so I'm going to start in the Atlantic. And so I'm going to start counting at the first non-zero, and I'm going to keep going. So, no, 1, 2, 3, 4. Okay, so let's look at this number. The decimal is present, so I'm going to start in the Pacific. I'm going to start counting at the first non-zero, and I'm going to keep going. So, 1, 2, 3, 4, 5. Everything after it is significant. Okay, so one more. I like 1s and 5s apparently there. That makes me feel better. So the decimal's absent. I'm going to start in the Atlantic. No. And then everything after it is significant. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So if you just need like a quick kind of thing, this will work. But I mean, I think you have the conceptual understanding of it too. So decimal is absent. Start in the Atlantic. If it's present, you start in the Pacific. And you're going to start counting at the first non-zero, and everything past it is going to be. Do you have a question? Y'all good?
Did you come up with that?
I think I saw it when I was doing summer work for AP Chemistry. I saw it like on a little random worksheet somewhere, and I was like, that's golden. All right, so let's go back to the PowerPoint, and we'll continue where we left off. I think. It kind of hides from me. There it is. And then play current slide. Alright, so that's really nice and straightforward. There's a little bit more to it. It's not super hard, but there's a little bit more to it when you start multiplying and dividing and adding and subtracting. There's a little bit more to it. Okay? So, when we're using multiplication and division, the number of sig figs in your answer has to be the same as the number of sig figs in the number with the fewest. So let me show you this. Here I have 6.38. It has 3 significant figures, and then I have 2.0. It has 2 significant figures. So you're going to put this in your calculator, and your calculator, of course, doesn't know significant figures. There's no button for that, okay? So, on most of your calculators anyway. So the answer, I'm going to get a certain number in my calculator, but then I'm going to have to round it to only 2 significant figures because the number with the fewest had only 2 significant figures. So it's pretty straightforward if you know how to count your significant figures. So, on this one, like I said, your answer has 4. That's not okay because your fewest has 2. So you're going to need to round it. You're going to round, like always. There's some crazy rules for if it ends in 0.5 and all kinds of stuff. We're not going to worry about that too much. But, you know, the last digit here, the second digit is 2. And so you look to the next one. If it's 5 or above, you round up. If it's less than 5, you keep it, right? That's just good old, like, 3rd grade math. So don't go crazy with rounding. You know how to round. I'm teaching you sig figs today. So go ahead and get this down, and then we'll do some practice with our boards, okay? All right, you ready? You don't have to have a calculator out. I'm going to show you what your calculator would say if you were to multiply 3.24 times 7.0. I need you to write down the units and get used to doing that. So I want you to write your answer. Here's what your calculator would say. I want you to write your answer over here. And I need you to tell me the units as well. So with your marker, don't worry about writing on your paper right now. Give me your answer for this first one. Round it appropriately. All right, let's see what you got. And I see all right answers. Get you a new pen, Lindsay. And I see one person that only wrote down, oh, I see what some of you guys did. You wrote down 2 for 2 significant figures. So I wanted you to write down like 23. So you're right, there are only 2 significant figures. Here, Lindsay, can you catch? I know this one works. You feeling okay? Are you sure? Okay. Yay! Whoops. Alright, so division is the same as multiplication as far as the rules. Your answer can have the same as the one with the fewest. And so there's your 2 numbers, and that is what your calculator is going to give you. And that's really, that's realistic for what your calculator does. And you can see how, if this is what you started with, there's no way to any degree of certainty you knew all these decimal places for sure. Really, there's no way to know. So anyway, go ahead and round it appropriately and write that answer and that unit on your paper. Or, excuse me, on your whiteboard. Very good. Yes, sir?
Is that G?
So that-
C
So that's grams per centimeter cubed, and that's actually going to be the unit for density when we do density on Friday. Because it's mass divided by volume.
It's a heart.
It is a heart. I know, I teach people that. I love density. Yep, I'm gonna do that. All right, let's see what you got. Good. I see some units missing, and we have, yeah. So let's take a look at this. We need to have 1, 2, 3 significant figures. So if I go over here and I start counting, that's 1, 2, and then this one needs to be rounded. So that's going to be the answer. I think some of you thought that 100.0 only had 1 significant figure, which is not true, because this instrument can measure to the nearest tenth, and then also if the decimal's present, you start in the Pacific. If you start in the Pacific and you start counting at the first non-zero, then you get 4. So either way, you want to think about it. It has 3 significant figures in the answer, because this is 3 and that's 4. All right, so let's take a look at this one. That's what your calculator's going to spit out. Write this on your board, please. Shouldn't take too long. All right, let's see what you got. Okay. Seeing a definite, about half of you, or maybe 60 or 70% of you got this one right. So let's talk about it. This .02 has 1 significant figure. This has 4 significant figures. So is this 0 right here, the 0.047, is this 0 significant? The second 0 is not significant either. So these 2 zeros right here, not significant, not significant. So 1 significant figure is going to be 0.05. Do you see? So if you wrote down just 0, if you just wrote down 0, then that's not the same. All right, let's try another one. So that's what your calculator is going to give you, which is not okay. It's funny now, but you would look at this every day in math class and not think twice about it. And of course, the units is meters per second, because you took a meter and you divided by a second. So this would be like a rate, like speed. You feeling good about it? All right, let's see. I see a lot of people, a lot of you guys got it right, but then a lot of people wrote down 24. So 24 meters per second, if you wanted to write down 24 and 240 are not the same. The answer is 240. So you guys understood that you could only have two significant figures. So what that would mean to you is you would write down the one significant figure, the 2, and then this next one you have to round. So you go 2, 4, and that final 0 isn't significant. So you can write it down and it doesn't count. So the answer is 240 meters per second. See it now? So you were right to only write down 2 and 4, but you do need to put that 0 in there because that's talking about 24 versus 240. Feeling okay? Got questions about that? All right, let's look at another one. And that's what your calculator is going to give you. Yes, ma'am.
I thought you said the answer can only have the least number of
Yes.
significant.
So final zeros without a decimal are not significant. So if the decimal is absent, you start at the Atlantic, and you start counting the first time 0, 1, 2. Also, this instrument would only read to the nearest tens, and that 0 on that ones place shows you don't really know. Now, as soon as I put a decimal, if I put 240 decimal, then it has 3 sig figs. So if you're ever stuck in a situation where you know the answer is supposed to be 240, and you can't get away with it by throwing a 0 on the end, you could always write a times per notation. 2.4 times 10 to the first. And that's another way. But it has to be numerically equivalent, right? 24 and 240, they're not interchangeable. So there's a couple ways to get around it. But that 0 is not significant. As soon as I put a decimal here, it is. All right, so let's see what you got here. I'm hoping for good things. All right. Most of you are correct. A couple of you have very generous numbers of significant figures. So let's look at it. Look up here. This has 5 significant figures. How many does this one have? 3. So how many can my answer have? 3. All right, so look. 1, 2, and this one is the one I'm about to look at to round. So 5870, that last 0 is not significant. 1, 2, 3, 1, 2, 3. Okay. Let's look at one more. There's the answer from your calculator. You guys are doing really well. Most of you are getting most of them, but got a couple little errors. Be very careful. That's better, sir. All right, let's see what you got. Come on, 100%. Much better. You're right, but you rounded too much. So let's look at it, okay? So I can only have 3 significant figures. Most of you got that. So look, 1, 2, and this one right here is the one I'm going to need to round. So 1, 2, and that third one. So that gives me 296. Some of you guys rounded up to 3. And if you wrote down 3.00, well, that does have 3 significant figures, but you didn't need to round that much, okay? And so those are those. How do you feel about that? Kind of getting it down? We have some practice. We're not done. Yeah, get these down on your paper. You just Now, when I'm finished, you have more practice, so if you don't feel 100% comfortable yet, that's okay. We're going to practice some more tomorrow. I know this takes time. Alright, so I want to show you something before I explain this next point. There's just one more little part to this. So let's say that I took some copper and I went and I weighed it out on the balance from yesterday, the one with 1 decimal place. Let's say I weighed out some copper and I got 5.2 grams on the balance, the little tiny one that we all weighed our pencil on in here. And then let's say I went to the lab and I weighed out some copper and I used the analytical balance and I got 8.2012 grams of copper. together, I'm sure about this bottom number. I'm sure about this number, this number, this number, and this is my last significant figure. It's my rounded digit. Do I know anything about this, this, or this decimal place? I have no idea what those numbers are. I really have no idea. So when I go to add these together, I mean, if I just do normal addition, this is what I get. But I have no idea what that actually is. I don't know. So when you're adding or subtracting, you don't look at the whole number. You only look at what's after the decimal. And the one with the fewest after the decimal is kind of the one that runs the show. So the figure that has the fewest digits after the decimal is going to decide. So I'll show you another example, and we'll do some practice on this, and then you have some more practice to do. So you're going to be okay. Let's go back to this. I'll start this slide there. All right, so with addition and subtraction, it's a different rule. And so you're going to go with the decimal places that has the same as the one with the fewest. So if I'm looking at my two numbers, I have one decimal place in 6.8. I have three decimal places in 11.934. Okay, I can only have one decimal place in my answer. So you're going to put in your calculator, you're going to get a number, and then you have to use your brain. So here, I can only write down 18.7. And the total number of significant figures doesn't matter. It's only after the decimal that I need to worry about now. Okay, so my answer can only have one decimal place because this only had one decimal place. And this is just showing us the level of precision of these measurements. That's how we're making this decision. All right, so let's go ahead and do a little bit of practice. Put your paper to the side, get your marker on your board. So here's my first calculation, and that is what my calculator is going to give me. So now, think about what you need to do with that number that your calculator gives you. And then write it on your board. Don't forget your units. And let's see what you guys have. Okay, good. I only see one incorrect answer, and you still have the right sig figs. So 10.2, I can only have one decimal place. So that last digit can stay 2. I saw one person that changed that to a 0. We don't need to do that. That 0 is still significant. So 10.2 is a better answer. Let's try this one out. Write this on your board for me.
We don't round all this, though, do we?
So you are going to round to that correct decimal place. So if your last decimal place is a 4 and it's followed by a 7, then absolutely you would round up to 5. Yeah. So you're rounding like you would in math class. You're looking at that last decimal that you're concerned with, and you see what follows it, and you round appropriately. Yeah. All right. So let's see what you got. Good rounding. Yay. Much better. Awesome. All right, so it is 76.3. Good. I like that. I didn't see any wrong answers, but if you need some more practice, we got it for you. Here's the next figure, and that's what your calculator is going to give you. All right. Let's see. All right, let's see what you got. Most of you are on the, I see most of you have it right. Some of you guys are thinking about significant figures. So I have 2 places after, or just overall significant figures instead of looking at the decimal. I have 2 decimal places here. I have 3 here, so my answer can only have 2 decimal places. So I need to go 2.39. Some of you put 2.4. If I put 2.4, I only have 1 decimal place. Adding and subtraction, you're just looking at the decimal places. Overall number of significant figures is 1 multiplication or division. So check this one out. There's where your calculator is going to give you. Show me your answers, please. Good. I like it. I see one error. I only have one decimal place here, and I have 3 here. So my answer can only have one decimal place. So 709.2 is correct. Got it? All right. So let's do one more. That's what your calculator is going to give you. Careful. I think there's one more after this. I'm not lying when I say just. All right, so, oh, I see some people still writing. Give them a second. Okay, show me what you got. Yes, good. A little bit off on the front here. I have one decimal place on this 18, 18.2. So my answer can only have one decimal place. All this stays, and then one decimal place. So there's my answer. And then this last one is tricky. Let me talk to you first before you write anything down this last one. This is a calculator that you put in the numbers into. Think about what a calculator is going to do. And now think about your rules. So go ahead and give this one a try. That's what your calculator is going to say. Now think about the rules for significant figures. All right, show me what you have. First period really messed this one up, so, ooh, looking good. Finish if you need to. Don't forget your units. Nice, you didn't let them trick you. What'd you have?
Oh, I didn't see the number.
Oh, okay, you want to try it real quick? Versada, it's okay.
If I get it wrong, you guys can just have it.
I'm not judging you. I'll judge you when I grade your test next week. Thank you. All right, so it actually is 0.160, and the reason it's 0.160 is because your calculator isn't going to run an extra 0 on the end. Did your calculator do that? No, but you have to do that because you're a person, not a machine. All right, so what I have for you guys now, get these numbers down, and then we have lots of practice. And for me, I know as a student, when I'm practicing, the first thing I want to do is I want to check to see if my answers are right. Don't you want to know right then if you got it right? So what I have for you is I have a couple pages of practice. They're really quick, not a big deal. And then the last page of your little staple thing is answers. Now, you could totally sit here and you could just copy the answers down on your paper. You could be done. But that's really not what we're about, right? So you have about 20 minutes. These are really quick questions. Go ahead and be cooking on these, and maybe after each little set, check your answers, and then ask me questions. And then we can, I don't know, learn stuff, praise talk. So give those a whirl. Just a heads up on some logistics. I'll hit pause on my little video.